Okay, so we are asked to find a polynomial given these specific zeros. So remember the theory that whenever we have the imaginary I, right, we have to have both the positive and negative of that zero. And the reason we need both the positive and the negative of that I value is because we need it to eventually cancel out, right? So let's find the polynomial given the zero of -2 and 1 plus 2i. Right, so let's write out our binomials. So f of x is going to equal x plus 2, x minus, and then in parentheses, 1 plus 2i, close big parenthesis, and then x minus 1 minus 2i. And notice how we have that minus sign, right? This minus sign is always the same, okay? So that doesn't change. Just the minus and the plus side inside right next to the I change, okay? So now we can distribute out, right? So why don't we distribute the I parts out first, because they look a little bit more difficult, right? So x times x is going to give me x squared. X times that negative long part is going to give me negative x, in parentheses 1 minus 2i. And then we have a minus x times the other 1 plus 2i, right? And then we have the 1 plus 2i times the 1 plus 2i. So actually, let's do that to the side real quick. So 1 plus 2i times 1 minus 2i. And you'll see again why exactly we want the positive and the negative of that 2i. So 1 times 1 is going to give me 1. 1 times negative 2i is going to give me negative 2i. 1 times positive 2i is going to give me positive 2i. And then 2i times negative 2i is going to give me negative 4i squared, right? So right away I can see this negative 2i and this positive 2i cancel each other out. I also know that I squared is actually equal to negative 1, right? So we can substitute this I squared for negative 1, which is going to make that 4 positive. So, right, 1 plus 4 equals 5, right? So that whole distribution of that part is just going to be 5. Okay, so now just to make sure, let's distribute the x in and fully simplify, right? So x squared minus x plus 2i x minus x minus 2i x and then plus 5. So all I did was distribute the x's to the inside of the parentheses. Now we can see what we can cancel out, right? So this guy would cancel this one out. And then we have these two x's that are like terms can come together, right? So this part simplifies to x squared minus 2x plus 5. And this we still have to multiply against that first binomial in the front, right? So against this guy right here. So let's do that. So x plus 2 needs to distribute to x squared minus 2x plus 5. And that gives us x to the third minus 2x to the second plus 5x plus 2x squared minus 4x plus 10, right? And then we can combine our like terms. So the first like term I see is the negative 2x and the x squared, which actually cancel each other out, right? So let's start writing it out. So f of x is equal to x to the third power. We have this 5x and the negative 4x, which combine to give me just 1x, right? So we write x, and then plus 10. So there is our polynomial.